All right, we're going to go on to section or chapter 7, which is kind of cool. And chapter seven's big focus is on equations, inequalities, and functions. And what's kind of fun, I think, is we're going to be moving away from a lot of the working with decimal math and fractions and switching things between those different things that we were talking about, and working a lot more with variables. And in this first section, I think a lot of people have done it on Khan Academy, and it's pretty easy, but it's a good start. We're going to be talking about writing expressions using variables. So that's going to be our main focus. Writing expressions using variables. All right, now for the example, in this section, they have kind of a cool one. They have Sal, and he's on a cycling team. And his team has 6 people, including himself. And he wants to register for a race, but the race can only have 138 cyclists. Any more than that, and it doesn't fill. It's too full, and the cyclists will crash into each other, and we don't want that to happen. So the question is, what's the maximum number of cyclists that can already be registered for the race in order for him to fit his team onto the race? Now, it would be easy for us to say, well, 138, oops, that's a terrible 8, minus 6 would give me 132. So as long as I know that 132 haven't already registered, we would be fine. But if I want to write this as a variable expression, that's going to be what we're going to be discussing about today. Now, real quickly, let's recall what an expression is and how we can compare it to an equation. Remember, an expression does not have an equal sign. No equal. And it typically looks like this. We could say like x minus 14. And the equation does have an equal sign. And it looks like x minus 14 equals 35. In an expression, we can't solve. All we can do is simplify. We simplify expressions, simplify. And equations we solve. Because I can't figure out what x is when it's x minus 14 for this one here, because I don't have enough information to do that. However, I can solve this one, this x minus 14 equals 35. I can come up with an answer. So in this section, we're just going to be using addition and subtraction phrases only to write these little expressions that look like this. Okay, returning to our cycling team example, I could write that, say I didn't know how many people were on the cycling team already. I could simply write it as, well, x minus 6 needs to be more than 132 as one way for me to write this. Or I could write it like this, that however many people have registered x, and if I add 6 more, it has to be 138. Then I would be able to register. In fact, I should probably use an inequality here, but for this example, we're going to be good. Let's make a quick little chart and look at some words that we can often see. Some addition phrases. And subtraction phrases. All right, we can see the word 1 plus a, and we can rewrite that easily as 1 plus a. That's pretty simple. If we see this, 2 and b, oops, and b, we can write this as 2 plus b. And 4 more than c is going to be c plus 4. Now, there's going to be some other things that we can see when we're doing addition, but these are the ones that are going to be very common. Let's look at some subtraction phrases. Now, I'm going to move mine down here simply because I'm out of space, but hopefully you can make yours look a little bit better. So I'm going to write 4 less d. Oops. I can say is 4 minus d. 6 less than g. It's going to be g minus 6. And h, fewer than 7. It's going to be 7 minus h, because we are h fewer. Okay? Let's look at a couple examples. Once I do the first example, you are free to go on. For this section, you will be writing expressions and equations. So I'm going to do an example of each. Now, I'm kind of out of space, so I'm just going to go to my next page. If you have some more space, then go ahead and go on. All right, let's look at we're going to write an equation. We've got example 1. Equation for the following phrase. For a number plus 5 is 10. Oops. All right, x, I'm going to say is a number. Plus 5 is, which means equals, 10. Nice. Now, what's kind of nice for these problems is that I don't have to go through all the work of solving them. Now, this one is not particularly difficult. Hopefully we should be able to just see that our answer is 5. But we're really just working on turning our words into equations and expressions for this one. Okay, let's take a look at another one. Write an expression for 12 less than a number. All right, so 12 less means subtract 12. So I'm going to have a number, this one's going to kind of go backwards, minus 12. And that's going to give me my expression. Because I had 12 less, if I said I have $12 less than I have right now, or than I had yesterday, I would have $12 less I'd be subtracting. Okay, if you feel like you understand it, go ahead and go on. And I'm going to do 2 more examples, one of each, if you'd like to watch me do these. Example 3, let's see. Let's take a look at another expression. And we're going to do 5 more than a number. And here we have 5 more than a number. So I'm going to have my number. I'm going to add 5 more. Now, of course, I could write this as 5 plus x. It doesn't matter, remember, because of how addition is commutative. I can move them around however I want. Let's take a look at example 4. And here we're going to write an equation. 5 less than a number is 10. All right, 5 less than a number, so x minus 5 equals 10, because 5 less means like a negative 5, and I can put this however I want. Remember, I could also write it the other way, and I could write negative 5 plus x equals 10. it's the same thing, because in both cases, my answer is going to be 15. 15 plus negative 5 is 10, and 15 minus 5 is 10. All right, good luck, and go on.